Hello everyone, and thank you all for joining today's webinar. I'm Tommy Langnes, Head of Business Development in LYTT. James Ramsey, LYTT's product lead, is joining me to launch spotLYTT, LYTT's new and exciting cloud-based dashboard that live streams wells and reservoir data to the operator's workstation anywhere in the world. Today we're going to give you a sneak peek of the functionality and the features of this new and exciting product. In today's webinar, feel free to ask questions in the chat window. For the ones we will not answer live, we'll get back to you with a personal response. So James, are you ready to talk through today's agenda?
Yes, I am. Thank you, Tommy. Okay, so first of all, obviously, we're going to talk about spotLYTT, and that's our new standard for wells and reservoir visibility. We're then going to take a little bit of a step back and look at our overall sensing and analytics platform, explain how that all fits together and specifically how spotLYTT fits into it. Then we're going to look at some of spotLYTT's key features, and we're also going to give you a demonstration of the software actually in use. And then last of all, we're going to wrap up with speaking a little bit about some of the value that we've delivered. So back to you, Tommy.
Thank you, James. So spotLYTT is a new cloud-based visualization dashboard that gives operators unprecedented visibility into production performance and also health of each asset in their portfolio in real time. spotLYTT live streams insights from distributed acoustics and temperature data sourced from fiber optic sensors alongside other time series data to users anywhere in the world via the cloud. It provides oil and gas companies with an intuitive, secure, and also continuous way to view transformational insights in wells and also reservoirs. These insights enable asset managers to identify immediate threats and opportunities to perform their operational decision-making without needing to spend time handling and interpreting data. James, can you talk us through how spotLYTT fits within the LYTT product framework?
I can. The diagram we've got up in front of us now basically gives an overview of the whole platform and how it all fits together. And we're just going to work through this starting on the left and working through to the right to address all the individual parts. So over on the left-hand side, obviously we have to start with the data itself. In any deployment using DFO data, there's going to be a range of different sensor types. So of course, there's going to be distributed acoustic and temperature sensing, but there's going to be all sorts of other sensor measurements that are normally going to be produced in the form of time series data. The important thing to note here is that all of these different sensor types are compatible with LYTT Live. In fact, most of the examples we're going to give today involve using DFO data, be that DAS or DTS, but spotLYTT is actually a very powerful tool, even if you're just looking at time series data or just looking at depth series data. Moving across one to the right, we have LYTT Edge. So the first role of LYTT Edge is very simple, and that's just to upload data from the edge to the cloud. So in an oil and gas example, the edge would be the oil platform itself, next to the wellhead. But it also has a very important secondary role as well that I'll go through now. So certain sensor types, and DAS is a very good example of this, generate data at such a high rate, it's not actually possible to stream that data rate over the internet, so from the edge to the cloud. And this is where this second capability comes in. And this is and at this point is where we extract a lot of proprietary features from the DAS data. The purpose of these features is to reduce the data rate so that it's a low enough data rate to be streamed from the edge to the cloud, but while still maintaining all of the key information in the signal. And we've spent a lot of time working on these features so that we can achieve exactly that. Next up, moving again one to the right, we have LYTT Live and the LYTT apps. So LYTT Live includes all of our data processing and data storage and the services that serve the data to the front end. And of course, they also include the LYTT apps. And these applications are things like inflow detection and water detection, all the kinds of predictive algorithms that we've spoken about in our previous webinars. And then last of all, moving again one more to the right, we have spotLYTT itself.
Yeah, thanks, James. So we have heard now how Light apps are generating automated insights into spotLYTT. Would it be possible for the customer to implement their own algorithms onto this platform?
Yes, the example I gave just there was using Light's own algorithms. But if the client has its own logic or rule-based algorithms or predictive algorithms, any of these can be swapped in or run next to the Light predictive algorithms. In fact, taking a step back, the whole platform has been built in a very modular way. So if you just want one part of it, that works perfectly well. If you just want the edge upload capability to upload to your cloud infrastructure, that's perfectly possible. Equally, if you just want spotLYTT without any of the preceding parts, that's absolutely fine. Okay, next I'm going to speak a little bit about some of the advantages we get from using the cloud. So first up, spotLYTT is a modern web application. And what this means is that you can access it anywhere, anytime, on any device that has a web browser and an internet connection. This means that you don't have to worry about downloading desktop software or making sure you have the right license on the right machine or downloading data before you're able to view it. All of this is handled smoothly by the cloud itself. The next advantage we get from using the cloud is the way in which all the infrastructure has been built and designed to scale automatically. So our processing, our storage, the way we serve data, all of this is going to scale to meet demand. So if, let's say, for example, we've been working with a client and as part of a trial, they're just streaming a single DAS stream through our processing, storage, and algorithms, and then viewing that in spotLYTT. If at the end of the trial they then want to ramp up and deploy, let's say, 20 fiber streams, all of this will be handled automatically by the infrastructure. It'll all scale to meet that demand.
Yeah, so in practical terms, this would mean a scalable architecture can quickly add new user accounts, new wells and assets as per customer needs. Can also integrate and display a wide range of sensor feeds, not only fiber optics, and well-centric data sources to make sure all necessary contextual information will be displayed alongside fiber insights for optimum decision-making. The solution could also easily be diversified to other assets types. So it doesn't have to be oil and gas. It could be other sectors like security, linear assets, pipelines, smart cities, etc. So James, let us have a closer look at the tool.
Okay, here we go. So in its most basic form, spotLYTT allows you to view DFO data on a heat map. Now we do realize that just viewing, for example, DAS data on a heat map isn't game changing. But what we think is a game changer is being able to view inflow production profiles on a heat map that are displayed on all displayed in real time next to, let's say, a cumulative inflow profile that's generated automatically, which in turn is displayed next to your well logs or a well completion diagram. Being able to view all of this information side by side, automatically, all presented in real time, allows the user, whether that's a petroleum engineer or someone else, the ability to instantly understand exactly how their well or their asset is performing. And we think having all of this information at your fingertips really is something that's game changing.
Yeah, thanks, James. So, so we have spoken about automated insights. So can you elaborate how spotLYTT can be configured to identify other anomalies of interest in these massive and large data sets?
Yeah, we can talk about the algorithms we run falling into two different buckets. So the first of those is where the algorithm, like we've got here, like an oil production profile or water detection algorithm, that has been trained to identify a specific event. But of course, in practice, there are going to be lots of events that we haven't anticipated, that we haven't got a specific algorithm for. And this is moving on to the second bucket, and where we would deploy something like an anomaly detection model. This very simply is designed to detect and highlight to the user any sort of anomalous change in the data and the way it's behaving. I guess again, back to the cloud, one of the advantages we have here is that everything's stored on the cloud and it's ready and waiting for any algorithm to be run over the top of it. So whether it's anomaly detection or a trained prediction model, or our own algorithm or something developed by the client, it's all very straightforward to run those predictions.
Yeah, thanks, James. So basically, the dashboard enables the end user to embed workflows that optimizes production and effectively manages production risks of wells and portfolio wells. You can also use these insights to make a larger impact on field management and reservoir management, like improving your sweep efficiency through targeted water flood management and improve well placement decisions. So, James, are you ready to share with us some of the core functionalities offered in spotLYTT?
Yeah, let's do that. One of the first things I wanted to talk about is one of the first challenges we had to overcome, and that's finding an effective way to visualize DAS data. So the main challenge with DAS data is even after you've extracted LYTT's proprietary, run LYTT's feature extraction over the top, you're still talking about huge volumes of data, so tens of gigabytes a day. So if, for example, you wanted to view an entire year's worth of data, if you weren't using any kind of intelligent aggregation, you'd all of a sudden be talking about terabytes of data. And of course, it's just not possible to view that amount of data and load it in any sort of reasonable time frame. What LYTT's algorithms do is pre-process the DFO data so that you always have the right resolution data available to you. So whether you're wanting to look at years of DAS and DTS data to detect long-term changes in the well's behavior, or zoom in on a specific event that might only last a few seconds, we pre-process the data to make sure the right resolution that you need at that point is always available and can be loaded very quickly. I think a good way to try and understand this is to compare it with something like Google Maps. So if you imagine you're looking at a satellite image of the whole of the UK, obviously that image isn't a stitched together of all the highest resolution data image that Google has. That image has been pre-prepared, pre-rendered for you so that you can load it very quickly. Equally, if you zoom in to look at, say, your back garden, then the highest resolution data that you need to do that is also available to be served up to you. In some respects, the Google Maps application is actually slightly simpler than ours. In Google's case, their two axes are latitude and longitude, whereas for us, we're dealing with depth or length along the fiber and time. And of course, time is always changing and moving forward, and that's created plenty of challenges.
Yeah. So I assume that there is an inbuilt capability to support broader integration and streaming of other time series data sources. So could you please share with us what level of data type support spotLYTT offers?
Yeah, so certainly the most challenging one to visualize is DFO data, as I was just explaining just then, but we apply exactly the same approach to visualize time series and depth series data. So we're pre-processing those depth and time series to make sure we've always got the right resolution of that data available. So whatever time range or depth range you're looking at, spotLYTT's going to be able to serve up to you your DFO data, your time series, your depth series, all in the right resolution, all available to you in sub-second load times.
Yeah, so I guess you can imagine that this user interface facilitates cross-functional collaboration, enabling effective operational decision-making to take place of the insights being presented. And it will also help you freeing up time to focus on implementing your production enhancements operations. So I think that is a strong and compelling value proposition. So James, can you quickly talk through how these insights could potentially be exported to other reservoir management tools the end user is actually using on a day-to-day basis?
I can do that. Everything we've spoken about so far has been to do with visualizing the data, but spotLYTT actually also allows you to interact with your data. What we're seeing in front of us right now is some DTS data, and this is showing a warm back event. So this is where an injection well has been injecting cold water into the hot subsurface, and after the injection stops, the rock around the wellbore and the wellbore itself is slowly warming back up to the original temperature. What's interesting here is we can actually extract a lot of interesting information about how our well is performing by looking at the rate at which that temperature changes after the well's shut in. What the user has done here is generated a number of time slices. So on the heat map, these are these sort of vertical colored bars, and across each of those time intervals, we've generated the average, and those are displayed on the next plot along to the right. The great thing about these time slices, as we call them, is that they really highlight the way in which the temperature in the wellbore is changing. And as I said, this gives you a lot of useful information about how your well's performing. This information actually becomes even more useful if you can export it into another software package. So this doesn't just have to be temperature data, as in this example. It could be oil inflow rates from the oil production algorithm that you're exporting into a reservoir simulation history matching tool. It could be inflow detection that you're going to export into a petrophysics package. This ability to export data out of spotLYTT gives engineers the opportunity to very quickly update their understanding of how their asset is performing.
Yeah, it's great to see how actually these insights can add value to other subsurface workflows and other applications. So what about other exciting features which comes in spotLYTT?
Yes, so we're always working on developing new features, and we've got a lot in the pipeline. There's probably a couple of interesting examples I can speak about right now. The first of these is actually creating shareable projects in spotLYTT. So if you think of something like Office 365 or Google Docs, there obviously you're able to share a document with a colleague, and you can both be working and collaborating on that simultaneously. And we want to bring exactly this capability into spotLYTT. So we're working on projects where let's say a user has got an event that they want to show to a colleague that occurs at a very specific depth and time range, and maybe they've got some specific depth series and time series sensors that they're displaying alongside it to really explain exactly what's happening. We're making it so it's possible to very quickly pull together that dashboard and then share exactly what you're seeing with your colleague, and they can understand what you're working on. Another thing we're working on is the introduction of user-defined zonations with respect to inflow profiles. So we saw an inflow profile earlier in this slide pack, and there it was presented just as a continuous log from the bottom of the well all the way to the top of the well. What we're working on introducing is zonations, and let's say that so that we aggregate that inflow profile across specific user-defined zonations. So let's say we have 3 zones defined by the user, zone A, B, and C. With this new feature, it'll be very quick to extract the information that says, let's say, the inflow is distributed 40, 40, 20% across those 3 intervals. I think one important thing to note here is we're still a relatively young company, and we're not burdened with some of the technical debt that you might experience with a larger corporation. And this means that we're still able to develop new features and new processes at a very high rate. So, if you're interested in any of the new features, be it the ones that are currently in our backlog, or you want to inquire about the feasibility of introducing a certain feature to spotLYTT, then please don't hesitate to reach out and ask us.
Yeah, so thanks for talking through the benefits of and functionality of spotLYTT, James. So, but I guess it's time for us to start demonstrating the tool in action.
Yes, I think it is. So I'll bring that up right now. Okay, here we go. So first of all, what we're seeing here is the drop-down menu. This is very simple and just allows the user to select which feature they want to view on the heat map, whether it's a DAS frequency band or, as we're seeing right now, the inflow detection algorithm. Next, we're adding some depth series data. So we've got gamma ray and permeability. And then after that, we can add a little bit more time series data. And this just allows the user to really understand how their asset is being operated at any point in time. Next, of course, is the key spotLYTT functionality, and that's the ability to zoom in on your DFO data. We can do that using the box zoom functionality, or as we're seeing right now, we can start panning around, so you can move to the left and to the right and up and down in depth. Obviously, zooming in is just part of the story, and we also want to be able to zoom out as well. One of the things that spotLYTT makes it really easy to do is to very quickly zoom out and pan across large time ranges. So right now the user is panning backwards in time to zoom in on another point of time that's of interest. And as you'll see in a second, this is actually the first point in time when this well started producing water. That's going to be highlighted quite nicely by turning on the water detection algorithm. Okay. There's our video. Let me just quickly bring back up the slides. Okay, back to you, Tommy.
Yeah, well, thanks for a super demo, James. So let me quickly summarize the key spotLYTT benefits we have been presenting today. So spotLYTT is a cloud-based visualization system built on top of LYTT's cloud-based sensing and analytics platform, which is called LYTT. You could easily choose and display insights in any time and depth range of interest in this tool. The automated insights are being presented in real time, improving decision-making and operational efficiency. You can also implement your own customized algorithms on the platform. It offers fast and secure access to your insights anywhere in the world through a web-based browser, so no need for a desktop application in this case. The LYTT solution is industrially proven, and it offers a compelling value proposition. It has generated more than $1 billion worth of value to our clients so far, enhancing operational efficiency, optimizing production, but also reducing operational cost. So thank you all for joining us today. We hope you have enjoyed the seminar. Don't forget to book a full personalized demo that highlights the value of spotLYTT for your business at sales@lytt.com, or you can reach out to us to discuss how we can pilot this technology and prove the value to your operation. Have a great day, folks.
Thanks, everyone.